Okay, looks like we are live. Just had my dinner, and then the first article I saw is this: Kubernetes made my best engineer quit. So the message says, um, I don't think I want to work on Kubernetes heavy systems anymore. I mean, like, he was exhausted by Kubernetes. This is expected because Kubernetes is um, quite complicated. It's not that easy, and you would require people with uh, strong Linux experience, as well as networking experience and a good understanding of the systems to be able to manage it well. We can look at the background. You can see we are talking about a backend engineer here. So um, Kubernetes isn't hard because engineers are weak. It's hard because we've turned it into a second operating system nobody actually owns. The thing is, Kubernetes is not for everybody. Kubernetes is designed for massive scale, like massive scale. So when you are starting with when you are building your product and you know that you are managing only three or four microservices, and you know that you have small to medium level scale, I think Kubernetes is not a great fit. Kubernetes comes into picture whether when you have 10 plus microservices and you also have a team who has a clear understanding of what Kubernetes is, of how things work, and you also have a clear compliance requirements. Like if you are getting into a project where you have so many restrictions, sometimes if you are building a product that needs to be hosted on premise, hosted on different clouds, so portability is a very strong feature that comes with Kubernetes. Um, if you don't have any such requirements, if you are sticking with one cloud, and if you have just four or five microservices and you don't expect that level of scale, Kubernetes is not needed. But anyways, so let's move on with this topic. When Kubernetes stops being infrastructure and starts being product, in theory, Kubernetes is just an orchestration. Yes, it is an orchestrator, but it has so many things that it can do. In reality, it quietly becomes the job. Yes, it is the job. You need a specialist to manage it. Um, but it doesn't mean that uh, everybody cannot learn it. It is a skill that can be learned. If you have a software engineer with 8 years of experience, if he or she can spend a month or two to understand the fundamentals of the systems and basic understanding of hardware, and then they can start working Kubernetes, learning Kubernetes. I think it's still learnable. You don't, you may not be able to learn each and every aspect of it, but if you are have a setup that is already set up, and you are just managing it, I think it's pretty much learnable, and then you can still manage it. um, you start with good intentions, will standardize the deployments, will auto scale properly. This will reduce ops overhead. Yes, I think Kubernetes is very good at doing this. It will standardize the deployments. I mean, you just have the GitOps in place. All you have to do is just checking your code into your GitOps. Everything is triggered automatically. I mean, like your CI/CD pipelines triggers automatically, and then your Argo CD picks up your latest changes. Everything goes seamlessly. I think this is the maturity level of Kubernetes is remarkable. Um, Autoscaling also works. There are scenarios where autoscalings do not work as expected, but again, they are edge cases. If you have anywhere between 300 to 500 node clusters, and if you have configured HPA, I think with standard CPU and memory metrics, you should be able to manage. It will reduce ops overhead. Yes, it will also reduce ops overhead if it's configured right. And but for some reason, if it's not configured right, and the if the only engineer, if you are left with one or two engineers who should manage the entire cluster, then it becomes obviously a big headache, right? So 6 months later, your engineers are debugging pod evictions, yeah, behavior at 2 a.m., sidecar memory leaks, Why say same YAML works in staging but explodes in prod? Why CPU limits exist but don't behave like CPU limits? I think again these are known problems. But if you have a specialist in place, I think he or she should be able to manage this very efficiently. But for a pure engineer, I think yes, some of them are hard to manage, especially the eviction strategies that Kubernetes has. Um, it is hard to debug. It has to be planned well. It's totally understandable. At some point, features were becomes the side quest. Kubernetes becomes the main storyline. There are instances where Kubernetes takes so much of time. And the worst part, nobody feels confident enough to simplify it. There is nothing you can simplify. I mean, like Kubernetes is complex. I mean, not everybody agrees to it. Um, it's hard to simplify as well. Um, But if you have, again, as I said, an engineer who has a good understanding, especially a DevOps engineer or a SRE engineer who is trained to manage this stuff, I think you should be able to manage it because Kubernetes brings so many good things for you. Enables you to scale. It enables you to bring a lot of compliance. You should also, do the transition from cloud to cloud or cloud to on-premise. If you want to connect your on-premise system to your cloud, uh, I mean, like there is so much Kubernetes can do. So if you have such requirements, I think it is worth investing in one or two resources, people to actually manage your Kubernetes cluster. Right. Yeah, YAML graveyard. I think again, this it's not really complex, and YAML managing YAML in these days is pretty easy because you have ChatGPT. It can be managed. Um, we audited our clusters during a reliability review and found that 40% of YAML files did not hadn't been touched in over an year. Multiple help charts deploying the same patterns slightly differently. Resource requests copied blindly from old servers. This is one problem that I see everywhere. Um, People do not actually do the thorough analysis of what a microservice requirement is. Look at it for microservice. Let's say if you have a Java service, let's say you have a Node service, and let's say you have a Python service. These three applications work differently under different circumstances. It also depends on the total number of requests they are receiving, and also the amount of work each and every API does. So the spec of each pod will vary from service to service, and the only way that you can configure it is by testing. At least you need to have 1,000 concurrent users shooting up in the microservice, and measure what is the minimum CPU and memory required for this to handle the load, and you can take that as your initial benchmark, and from there you can adjust your pod specs. It's like shooting on your head to copy paste a spec that is for Node.js application to a spec that requires I mean, like for a Python service that is running an ML service. You cannot do that. I think this is something that needs to be corrected by everybody. um, Auto scaling configuration that nobody could explain anymore. I think auto scaling is something it's pretty standard. Again, once you do this concurrency load testing with 1,000 users, you can clearly configure that. I think if you have 1,000 concurrent users, you know that your maximum CPU threshold is 2 cores. You will also know that your maximum memory threshold is 4 GB. Once you have that baseline, it is easy for you to configure your auto scaling also. So these two things clearly depend on how you are doing the load testing. And once you have a clear load testing in place, I think it's much easier for you to configure this and run through this, right? And every engineer assumed someone else understood it. No one did. Kubernetes had turned into an institutional knowledge. I don't know what that means. Invisible, growing, and quietly expensive. Yes, it is. I mean, like, again, as I said, you can consider Kubernetes into picture based on your project. I think it's not a straightforward shot. There are so many things that come into picture, and at least in the beginning, you need an expert to look at what you're doing, uh, to understand what you're doing, and to even, I mean, like, this will help you to even understand whether you need Kubernetes in the first place or not. I think there is a joke around level 1 to level 5. Level 1 guys know some set of Kubernetes, level 2 guys know some set of Kubernetes features, and level 5 guy is the only person who knows whether your project needs Kubernetes or not. So it's a fancy joke, but yeah, understanding whether you really need Kubernetes is a skill itself. But anyways, I think um, I think like emotional cost nobody budgets for. People talk about cloud costs. They don't talk about cognitive costs. I think again, this is, I don't know why this was mentioned. Kubernetes demands, yes, deep Linux knowledge. You also require network intuition. I don't know what they mean by network intuition. I think network fundamentals of network is absolutely required. You should also have a clear understanding of distributed systems and constant context switching. I don't know why what constant context switching means, but anyways, I think this is fine for platform engineer. As it was rightly pointed, you definitely need some sort of platform engineer to manage, or a DevOps engineer to manage your Kubernetes cluster, especially if you are managing things at scale. If you are not managing things at scale, you do not need Kubernetes in the first place. If you are running in AWS, I think you can very much choose ECS, which is the container service, or you can go with native VM deployments, or because VM deployments are not bad, because I have handled many applications running directly on a VM. If you are sitting on on-premise, you can still run on-premise systems directly on VM. They are quite good. If you have experienced people who can manage your physical servers, you can directly run on the bare metal. It's best option possible if you are running on-premise, unless you have a huge scaling capability that is coming in, and you have multiple teams running multiple projects on a single hardware. Then I think Kubernetes is handy. But if you're running a single project and you have a single hardware dedicated for it, I think, yeah, you can go ahead and directly run it in the bare metal itself. Um, Again, as I said, but we pushed this complexity onto I think it's a blunder. Uh, you cannot push the complexity to backend developers. They do not have that expertise to manage Kubernetes. Right. Eventually, good engineers stop asking questions. Yes, I think the problem with good engineers is always they don't ask questions. They keep silent, and they do what they wanted to do. And then they stop proposing changes. Then they stop caring. And sometimes they leave. Not sometimes, many times they leave. But uh, as I said, like, this is fundamentally a question of understanding your project requirements, and the complexity of the project. Then you can take a decision on whether you want to run your project on Kubernetes or not. If you choose to run your project on Kubernetes, it is always wise to have somebody, at least one person, who can manage your Kubernetes cluster. That one person can scale the other engineers how to manage things and stuff like that, so that developers eventually catch up. If there is anything major coming up, you have one person who's managing your infrastructure, and he or she should be able to troubleshoot things. Rest of the small things can be managed by developers. um yeah, this was an interesting read, I should say. But i don't think um I don't think developers should ever be scared of a specific technology, especially the engineers. Any technology can be learned. It's just a matter of time, investing your time into doing this stuff. If you have to learn it on your own, it is quite challenging. With proper training, anybody can learn Kubernetes. I think the problem here in this scenario is pretty much the backend engineer is overloaded with his own tasks as well as managing Kubernetes. I am not really sure if the person is trained enough, or he is expected to train himself by himself, which is again a hard task. But if somebody is actually getting trained with the right trainer, and then they have enough time to manage the infrastructure, and if they are given enough time to manage both the as well both the coding part as well as the infrastructure part, I think this is manageable. But if the person is getting overloaded just purely for the development work and they cannot handle the infrastructure layer, I think is quite a challenging thing. Right. That's it for today. If you find this useful, drop a like. It really helps. Subscribe if you find this channel useful. I'll do more of this live streams every day. Um, do let me know if it is useful.